Hey everybody, this is Larry. This is me doing week 5 of the weekly premium challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. And apparently on Thanksgiving Thursday, they give us Leetcode gives us not just one but two hard problems. So we'll take a look and see. Today we have 2204 distance to a site code in Oh, excuse me. In an undirected graph. Okay. Okay, so you have one cycle. It seems like so almost a tree, but you the way that I don't know. I mean, maybe it's not important yet, but I would think about for now. I think about it as a tree with an extra edge, right? So then now, okay. So you have some edges. The minimum number of edges that the minimum distance between ith node or answer sub I. So you basically answered for everything. Okay. I mean, the thing is that so if you think about it as a tree. Let me think, right? So the way that I'm thinking about it now is that with a tree, there's one unique distance from every 2 points. The minimum distance between the ith node and any node in the cycle. Whoops, I missed the cycle part. Okay, so actually let me step back for a second. Okay, first of all, we want to find the cycle, and we can find all the cycles, right? And that's pretty straightforward. I think we can find all the cycles, mark all the cycles, and then just for every node we can visit it and just do a DP type thing because there's only one edge to go, right? I mean, it's either go up or down, so it shouldn't matter. So I think this should be pretty straightforward, I think. Yeah, and then we could do a breadth first search actually, maybe not even a depth first search. That would be smarter, maybe. Right, so then and for now we're just setting up the adjacency list. Okay, right, and then we can just visit any node. Yeah, we can just do a breadth first search or a queue or whatever, and just see whether something is done. So we just have to find one node, right? And maybe the previous node. Or like, if you want to find like one edge. If you find one edge, then you can go find all of them. Right? Maybe? I mean, and you could also, do some other funky things, but... yeah. Yeah, I mean, I think we could. I think I'm just gonna be a little bit crazier, even, right? I'll just kind of find one node that's in the thing, and we can do that very easy from. Yeah, we can just go. We search from A, right? Or from 0, sorry, right? And we just don't go from the same path that we done, right? And then that's it. Right, for you, or for we in E of node, if we is not equal to parent, we search we node, right? It's basic stuff, and we just have to just mark it as like force is equal to times n, right? Okay, so we're gonna mark scene is, and you could even use colors if you like. Yeah, true, right? And then here it's just basically yeah, if done of v is true, then Yeah, none of V is true, then V is the thing, right? So yeah, maybe I'm doing a little bit terrible code is what I was gonna say. Right, and then okay, so then now we will find a node, right? Just to kind of want it. And this is node 3, which is in it, and then node 2, which is true, right? So okay, so we know that found is a node in the cycle. So then now, how do we want to? Oh, and yeah, and then the previous node is actually, or the parent should be a thing because yeah, because this is the second time. So the second time. So okay, yeah. I'm just trying to think like, so for example, if you're here, we know that the two nodes that are in the thing, right? So 2 and maybe 2 and 1 or something, like it goes from 0, 1, 2. Then how do we, you know, it goes from 0 and then, or it goes from 2 and then 1, right? I guess I actually found some node. I guess we could have done this actually. Yeah, I guess we could have done it here in the current path, right? This is very ugly code now, actually, but yeah, maybe path.append node, and then if it's done, then found is equal to v, and actually maybe we want found instead of equal to v, we want to say something like yeah, we just do like path.index of v, and then path from that entry on, something like this. This is very ugly actually, but that's good. So that should be the cycle, right? Because if it's done, then it should have been there before. Then why is it that this is not quite enough or what I expected? So 3, right? Oh, I don't, so this is, I think this is a little bit awkward actually. I think it should be this, and then path dot pop, just like a thing. So then now maybe it's a little bit cleaner, but then 3 is not on the list. That's weird. Oh, because this thing, yeah, okay, maybe this is a little bit awkward. Do I have another? Oh, I penned V. No, not V. That's why. Okay, there we go. I mean, okay, it's at least this looks a little bit better. It goes 0, 1, 2, 4, 3. If done of V, that's awkward. Oh, V is the next node, but why is it V is not in the list? But V is 1. Oh, this is the second part thing. Okay, that's why I was looking at the wrong graph. Okay, so maybe the pop is a little bit weird. but that shouldn't have, so it goes 0, 1, 2, to go back to 0, so then now 0, 1. 1 doesn't connect to 3. Why is it? Oh, 0 connects to 3. But if it's found, then we just return, but then this return, so then it's a little bit awkward, I think, that's why. And then 3 wouldn't have been revisited. I don't get why. It's a little bit awkward, actually. Okay, so path 0, 0. It was basically reset. Why does this work? I mean, oh, because then it does the next iteration, and then, but done should not have been done. Oh, because it's still searched, maybe. This feels very wonky, honestly. Like, I don't know, I don't get why this is. Okay, so it goes 0, 1, 2, and then the 2 it pops back, so then now it goes to 0, 1 on the tree, on the stack, and then the 1 we pop. Oh, because this returned before we popped the. Is that true? I don't know. This is so weird, actually. Sorry, Fred. I'm not explaining much because I'm still exploring it myself, but I think this part is just coding. It's just about finding the cycle, right? And you find the cycle by just like looking at the tree. But yeah. Node is, so it goes 0, parent, 1, 1, 2, 2, 4, 2, 4 is awkward because it doesn't really exist. Right? Am I looking at the right problem? There's no 2, 4. Why is there a 2, 4? 4, 2. Do I change parent in any other way? Yeah, why? Do I have typo on this? No. Do I? No. Huh? We and ye of node. Okay, so for node, for 1 we have 2, 3, and 0. That's not true. Huh? Am I going nuts? Did I reuse variable somewhere? Am I looking at the wrong problem? I'm looking, this time I'm looking at the wrong problem. I'm looking, it should be the first one. Okay. Maybe then it's right. It's just that, okay, maybe if we don't pop correctly, then 2 is equal to 4, and then, okay, 3 is not on the list anymore because we don't return an, okay, so then it goes from 0 to 1, okay, fine. 1 to 2, fine. 4 to 3, 1 to 2, 2 to 4, fine. 4 to 3, fine. 4 to 1, then we found the thing, okay. And then 2 to 5, okay. And then now all the way back, we go from 1 to 3, I think. And as a result, we're like, okay, we already found 3, so then that's fine. Okay, fine. Okay, maybe I buy it now. I mean, I just wanted to audit it, even though it seems to be okay. But yeah, but now we have these. This is the cycle of things inside, right? So we can just do a breadth first search from there, really, right? Yeah, so then now distances of is equal to infinity times n, is it, right? And then now for x in found, distances of x is equal to 0, and then we just push it into the queue, right? Yeah, and then queue pretty, and then do a breadth first search, and we should be good. And then now while length of queue is greater than 0, we have current is equal to q dot pop left, and this is just regular breadth first search stuff. But yeah, so the way that I kind of found the cycle, I know that I didn't explain it at all, really. It's just that I go until I if you think about it as a tree, then as I said, there's going to be only one place where, well, you sort of know that you've seen before. And if you've seen it before, that means that that's a cycle. So then you kind of look at, well, this is the point where this is a node that you know that the node that you last seen is the node that is in the tree, but also it has two things pointing into it, right? And so if you kind of do a look at the stack of the core stack, then now it goes all the way back, and that's your cycle. And that's really it. I mean, it's all of n space. It's not the, I guess you could have also done like the cool way, but with what you might call it, the hare and the tortoise or whatever, right? So yeah. Anyway, for u in ye of current, right? If distances of u is equal to infinity, then distances of u is equal to distances current plus 1, and q dot append u. And that's pretty much it, right? So then now, yeah, and that's actually just the answer, right? Oh, I didn't define it. I usually do write it when I write it, but I guess today, I don't know, just a little bit off. Okay, let's give a quick submit, and there you go. Not so bad. I mean, not so easy either, because I made a lot of silly mistakes, but not too bad, hopefully. What did I do? I wonder what I did last time. I guess I did things like way crazier this time. It seems like. At least an idea. Maybe, at the end we did so we just do a cycle thing, right? But I like the way that I did it today, an idea, even though the implementation was way wonky. I think I could have done this with, this doesn't need to be a recursion. I think that's the kind of thing, but I don't know. Anyway, this is going to be linear time, linear space, because we look at each node once at most. You just do you can think about it, the search function is a regular depth first search. We look at each node, and then the distance is just going to be, also like a breadth first search, so linear. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, take your mental health. I'll see y'all later. Take care. Bye bye. Have a great weekend.